Something strange is happening at the far edges of our solar system. A handful of icy worlds are moving as if they're being nudged by a giant, unseen hand, perhaps the elusive Planet 9. But what if we've just found an object that moves against all the rules? A rogue world on a 25,000-year orbit has been discovered, and its existence challenges everything we thought we knew about our cosmic backyard. This troublemaker turned out to be a digital ghost, its tracks hidden for years in archival images of the sky. It was found by algorithms sifting through massive datasets. This technological breakthrough is precisely what makes the discovery so timely. We now have a piece of evidence that could either prove Planet 9 exists or shatter the theory entirely.
So how exactly do you find a tiny, dark object on a 25,000-year journey across the sky? What does this world's bizarre, lonely path tell us about the hunt for Planet 9, the biggest mystery in modern astronomy? And does its existence mean the edge of our solar system is far stranger and more crowded than we ever dared to imagine? To understand this discovery, we first need to get our bearings. This object is a trans-Neptunian object, or TNO, which is just a way of saying it's a small world that lives in the vast, cold region beyond the orbit of Neptune. With a diameter of about 700 kilometers, it's large enough that astronomers consider it a candidate for being a dwarf planet, a cousin to Pluto. This world wasn't found by someone peering through an eyepiece. A team from the Institute for Advanced Study created a custom computer algorithm to search through 7 years of archived photos from two major observatories, the Victor M. Blanco telescope in Chile and the Canada-France-Hawaii telescope. The program connected 19 faint dots of light, all moving together as a single object, revealing a world that had been hiding in plain sight. It's a discovery that shows us the frontiers of exploration are now found in data as much as in the sky.
And the place it explores is truly on the edge. This object travels on a path that can only be described as extreme. At its closest point to the Sun, it comes into around 45 times the distance from the Earth to the Sun, which is in the same neighborhood as Pluto. But then its journey takes it outward, swinging more than 1,600 times that distance away, deep into the interstellar twilight. Its path shows just how vast and mysterious the outer reaches of our solar system truly are. In short, we found a potential new dwarf planet on a colossal 25,000-year orbit by using computers to search old pictures of the sky. Now, to grasp the scale of that journey, imagine its orbit was a road trip across North America. On that scale, the orbit of Neptune, the farthest giant planet, would be just the first few blocks of the journey. The real breakthrough here is the method. For decades, finding these faint objects was a painstaking process of comparing photographic plates by eye. Today, the technique is far more powerful. Surveys like the Dark Energy Survey have created massive digital archives of the sky. The key artifact making this possible is the Dark Energy Camera, or DE-CAM, on the Victor M. Blanco 4-meter telescope. This powerful instrument captured deep images of the southern sky for years. Scientists then use computational power to shift and stack these images, layering them on top of each other in a way that makes faint, moving objects pop out from the stationary background of stars. It took sifting through 7 years of this invaluable data to finally pinpoint 2017 OF201.
The data revealed an orbit that is truly wild. Its path isn't just huge, it's incredibly stretched out. Astronomers measure this with the number called eccentricity, where 0 is a perfect circle and 1 is an orbit that escapes into deep space. The eccentricity of 2017 OF201 is about 0.95, meaning its orbit is a long, flattened ellipse. And this is where our story collides with the biggest hunt in planetary science, the search for Planet 9. The Planet 9 hypothesis was proposed by astronomers Konstantin Batygin and Mike Brown in 2016. They noticed that about 6 of the most distant objects we know of have orbits that are strangely clustered together, all pointing in the same general direction as if they're being gravitationally herded by something massive and unseen. One model suggests this hidden shepherd is a planet 5 to 10 times the mass of Earth, lurking hundreds of times farther from the Sun than we are. But here's the problem. The orbit of 2017 OF201, this new object, doesn't match the cluster. It's an outlier, an oddball whose path is completely different from the others that point toward Planet 9.
So what does this change? The discovery of a single outlier like this complicates the elegant story of Planet 9. It's a piece of evidence that doesn't fit the pattern. This forces scientists to ask a critical question. Is the Planet 9 hypothesis incomplete? Or is the outer solar system just more chaotic and complex than any one single theory can explain right now? It pushes the boundaries of our understanding. The consequences of this discovery ripple out across 3 different timescales. Right now, this object is a crucial, contradictory data point that is fueling intense debate in the astronomical community. Some theorists are running new simulations, trying to see if a Planet 9 could exist and still create a strange outlier orbit like this one. Other scientists argue this discovery supports alternative ideas. One hypothesis suggests that the gravity of countless smaller objects in the Kuiper Belt could collectively shape these orbits, without needing one giant planet. Another model suggests the gravity of a star that passed by our Sun billions of years ago could have stirred things up, flinging these objects onto their strange paths.
In the near future, the game is about to change entirely. A new generation of tools will give us the data we need to solve this mystery. The most important of these is the Vera C. Rubin Observatory, currently being built in Chile. Starting soon, this observatory will conduct the Legacy Survey of Space and Time, or LSST, which will photograph the entire visible sky every few nights for 10 years. It's expected to discover not just 1 or 2 new TNOs, but potentially thousands of them. This will give us the statistical power to see if the orbital clustering is a real phenomenon or just a coincidence based on the handful of objects we've found so far. We'll finally have a complete map of this hidden territory. Further into the future, understanding this population of worlds is fundamental to understanding our own origins. These icy bodies are pristine leftovers from the birth of the solar system 4.5 billion years ago. They are chemical time capsules. While a mission to visit an object this far away is beyond our current technology, the New Horizons spacecraft, one of the fastest ever launched, would need more than a century to reach that region. It remains a long-term goal. Actually landing on one of these distant worlds and analyzing its composition would be like reading the first page of our solar system story. It's a multi-generational quest that begins with discoveries like this one.
We started with the story of a lonely world on a 25,000-year odyssey. The answer to the puzzle it presents is not a simple yes or no. This object is more than just a moving dot of light. It's a clue, and a complicated one at that. The discovery of 2017 OF201 did not solve the mystery of what lies at the edge of our solar system. Instead, it deepened the plot, making the story bigger and more compelling. It proves that the vast, dark expanse beyond Neptune is not empty. It is filled with hidden worlds whose strange and ancient stories are only now beginning to be told. And each new one we find, each faint glimmer of light, helps us to map the true final frontier of our own home.